Well, I suppose it's time for an update, since I finally managed to figure this thing out. The complex math bit, uh, but actually I need to have a coffee. Hang on a sec. Okay, the kettle's going. The water is boiling up. Now in this tutorial here, everything I've been talking about for the last, I don't know, month or 2 months or however long, is all going to come together in one shot. Aggregation, calm idea, the marshalling concept, and all of that is going to come together in this complex math struct. It took me quite a while, in fact, to stumble on the answer, which turns out to be quite simple. Oh, there's my water. Yeah. See, now what I started doing, taking this real math as an analogy, I started taking the complex math and doing this sort of thing. Make a marshaller, make a new, instead of binary operations, you would have, 4 arguments and so on, instead of 2, and all this sort of stuff. Having forgotten, not conveniently, that I'd already solved this problem long ago. When I made this class initially, although it doesn't look the same anymore, it is the same, but now sometimes it has to change its name. Okay, so therefore, instead of this saying like the interface that it needs to derive from this complex math ought to be one of two things: either I complex math, which is defined in the header file here, and just generally in TS device, I've defined this other magical name, which is just a name called marshaled. It doesn't do anything, but it's like a name spacer. If you were an honest marshaller, then your thing that says marshaled will do the marshalling dance, or whatever you want to call it. Alright, so that's why I had to change this into a template. Now it turns out, instead of having to do any marshalling for my marshaled complex math, I don't have to do any marshalling, because the implementation of this class uses a real math object, right? And these real math objects can be marshaled. Therefore, that problem is already solved and needn't be solved again. Furthermore, and the reason I managed to stumble upon this answer, if I'm to hand out a real math, I don't have any function to do that, but if I did, and it was a marshaled complex math object, then the thing to be handed back ought to be a marshaled real math object. And that was where the trouble set in. As I was designing this, I had, the calls with the extra parameters to put on the queue and whatnot. well, those calls were still being redirected to this lowly old real math that didn't know anything about marshalling. And how could I hand that back to the client? Then they would, then they would lose the marshalling feature for the real subcomponent. So the answer is you don't do it. There is no marshalling code in this complex math, and there doesn't have to be, because the marshalling is done through this object, which is a delegate of something, and that something would be a marshaled real math object. Well, after figuring that out, I thought that was great, and everything was wonderful, and it was going to be a piece of cake. But I couldn't figure out how to get the declaration, how to see underlying this delegate thing is a function called uncouter. As you probably know, I think I've mentioned uncouter more than on one occasion. And I have a macro even for the implementation of uncouter. But in this case, this macro won't work for a number of reasons. For one of the reasons is there are two parameters to the template declaration, so this field offset macro would fail with too many arguments, and you have to be more specific. So I was trying to do it by hand, and I must have spent hours and hours and hours and hours all night trying to get the declaration to work. And here it is finally. I finally figured out how to declare it. It's very complicated because the thing kept saying requires template parameter. Your thing requires template function requires template parameters, or something like that, right? Plus, I was using the term real math in here, but I couldn't. It wouldn't allow. You can't do that. I have to be explicit and not, unfortunately, I can't. It's not really it's not a function of real math. In fact, it's a function of this delegate thing that I hadn't realized. And finally, what I did was I just commented these away, and it compiled, but it didn't link. And I just took the error report for the missing function, right, and copied the declaration from the error, and then it worked. Believe it or not. Well, I didn't know what to put in here, but I just guessed that at this point I shouldn't have to put any more template parameters in here. I think it's been defined. The name spacing has been clarified, but certainly by the time you're inside here, there shouldn't be any ambiguity about what these letters stand for in this scope. Okay, it works, it compiles. I can make a complex math or a marshaled complex math, and the method of creating is just a matter of, it could be a macro again. If it's unmarshaled, I make a complex math that derives from I-complex math and has an internal I-real math object. For the marshaled case, it derives from marshaled a complex math, actually not from that, from a ref counted. A ref counted that, so a reference counted marshaled I complex math, which isn't really a marshaled thing in itself. It's just named that way so that it supports the correct interface, and so that the function has the correct name, right? This is what I've got to return in this type. And internally, the real math object is a marshaled I real math, not reference counted. That's another one of the difficulties was where to put the ref counting, all this template declaring and so on. And I finally, came up with this declaration. It's very difficult to come up with these declarations. Should I just derive from one thing and specify, the ref managing as one of the template parameters? And that was very complicated, just to work out how to declare it. But in any event, it works out to be quite simple. Looking at this, you would think that there must be some way to make this a parameter, but I can't think of any way. In form, these are identical. There's no difference in the form of these two functions, right? The only difference is wherever you see I complex math here, you put a marshaled in front. Wherever you see a real math, you put marshaled in front. I can make it into a macro, certainly, but I don't think you can have a template thing that omits something. Or maybe you could, because I do have a template called type of. It's a template that takes an argument that simply is what the type of the thing is. Somewhere in header files. I actually need this thing for a specific purpose. It's called type of. Here, I didn't write it down, but there used to be a comment. The reason for having something stupid like this, where all it is a T, right? Whatever this is, and this struct is exactly one of these, is because, like for instance, sometimes I might want to make a locked integer, a mutex protected integer, but I'm not allowed to derive from integer, but I can derive from a type of integer, because that's a struct. So that's what the main use of that is. I use that in the M thread. Somewhere. Well, I don't actually use it explicitly. I use it, there are places where I use it in other projects. I say CS locked of int, or of type of int, and that acts entirely like an int that I can lock or not. I'll show you an example. I know I have one that I use in Notepad Q. Should find one in here somewhere. I have one like a percentage number that counts up when I'm loading a large file. Oh no, I know it's in here somewhere. I know I use it. Somewhere I use it. Not sure I was using it in here. Well, I haven't compiled this for a while. See, I used to use it and then I stopped using it and then I wanted to use it again. I stopped using it because, well, why is it searching those weirdo files? Like .scc. It's very strange. I should interrupt it. I don't want it to do that. What? Star of Dawn. Isn't that how it's spelled? Type of? My source safe has erased that stuff conveniently for me again. Oh, underscore. How about that? Okay. See, yeah, this is from the old days when I thought you were allowed to put underscores in front of things, but really you're not allowed to. So here's an example. Wait, it's not an example. A type of int, n% done, right? And if you look at the way that n% done is used, besides locking and whatnot, it's just a int, right? Set it equal to 0, set it equal to 0, n% done. Here, this is locking it and then returning it. The setting is not, this set is not thread safe. However, I think this is locked somewhere in here. This value should accurately represent file read callback. Doesn't seem to be wrong. It's not locked here. I know the assignment doesn't lock. No, that's odd. Not sure. But it doesn't look like I was being very careful. Maybe not. I might have had my reason. You know, this is making it lock. But locking it here doesn't mean it's not going to be altered, because if it's, well, let me check the assignment. This is a diversion now. I'll get to it in just a second. It's a, okay, now this is, if it's critical section auto release, plus plus is protected, but assignment is not. It could be, but there is a danger. In locking during an assignment, you might end up in a deadlock scenario if you do that. In any event, nothing to worry about here. So all we got to do now is just run this unit test and watch the magic happen. So I have two tests lined up here. I've created an addition of two complex numbers. This one is 2 pi. This is real, this is imaginary, real, imaginary. Eventually I'll hide this behind something like that fancy real manager. And the result has a real and an imaginary part, and I print out the results. Okay? So I built the DLL and I registered. I can unregister it if you want. No, you don't want to see that. We can certainly step into this create device. If this will run, and you'll see that just like before, the proper function name is located, and the DLL loaded into memory. It's all the same code. I printed out that should be the name of the function. I check in the registry and see if there's a DLL. There is a DLL, which I found. I use my quick copy and load library, get a function, and there it is. That's the correct function. I can step into this. Here we are in complex math create, which creates first a real math. So that winds us back in here again, which loads a second DLL, which is our aggregating part. Check the registry, syntax there, and again, the create function is located. It's the correct function, which puts us into real math DLL, which creates a real math pointer. And that succeeds. Since that succeeds, we can now go on to creating a new complex math of these two parameters. I also have at the end I have a printout of at least the destructor, so we can see what the class was named. That succeeded, and now I'm just going to add these two complex numbers and print out. The printout is in the same order, same numbers that appear here. You don't have to really step through it. show you that the answer looks correct. We'll put these in brackets for clarity. 6 and 4, certainly that's 10. And 1.5 and 3 is 4.5. Okay, so it's definitely the correct answer. Recall the release. Now I should step through this. Release here. What's going to happen when I press this? Nothing. Something got printed out though. This here destructor was called. It doesn't show that the other destructor was called because I don't have a printout for it. But the name of the struct is a complex math is my complex math of iComplex math interface and iReal math interface. And that works. There's no memory leak. And here's that same printout here. So these names are getting kind of long. Now, if I step into the add here, you'll see that these are just plain old function calls. Goes to the real math thing, which calls through the real math pointer, which is just a simple addition in the end. Okay? And it does that a few times. Now, I'm going to change this declaration to be a marshaled complex math. So now we got everything going. It's an aggregated object, composed and aggregated, and marshaled as well. And if I added the function, we could pull out the real part and use that on its own, and it would still be marshaled, and we could still obtain the outer object, the UncOuter, from that return pointer. If I had such a function, I might call it query interface or something. Okay, now I don't know why it's building all this other stuff. Oh, Notepad Cube. I don't want to build that. I haven't built all my utilities, which I have to do. I have an idea. I'm going to put all of them in the same directory. I'm going to make a super installer to install all my little utilities in the same directory so they can share those DLLs. Okay, so this is just a declaration. Create device. Again, a funny name. It's generated. This is the function that, as it should be named in the DLL. Check the registry. It happens to be there. I already registered it. Load the library. It loads fine. The procedure is located. And here it is. I declare a marshaled real math and create that, which puts me back in here again. Happens to be in the registry. I don't know what that was. Oh, because I'm starting it. No, I don't know why that took a while. Calling the create function. My marshaled math, which is this thing that has the thread procedure. So that starts up a second thread. Now we got two threads going, and that succeeded. Since that succeeded, I can now create this object, which is really doing nothing more than what the other object does. In fact, the code is exactly the same, right? No difference. It's just got a different name and a different internal object. Now when I go to add these two imaginary numbers, that is referred to real math, which puts us in here, and this is no longer a direct call, this is a marshaled call, which will, by the time we get here, will have been invoked through the marshaller in the other thread. And the marshalling thread, which now calls invoke, which invokes the addition function of the real math object that we already built, signal the operation is complete, and in this thread we should wind up here eventually, and that was one addition, and then there are several. No, I just quit. But if I do this, there's the sum, same as before, and the name of the struct this time was my complex math using a marshaled iComplex math, implementing a iMarshal complex math interface, and it does that using a marshaled real math. And so therefore, we now have a complex math object from which I'm going to add to this abstract algebra, abstract complex, CPP, which will deal with complex numbers, and marshalling or not, that will be hidden in the construction of the main object that everything will use. Just as before, there will be a shared, locked, reference counted iComplex math of either marshaled variety or not. And I'll just write another, instead of get real, get complex. And I'd like to find a way to represent those numbers that will look like complex math. I think that could be done if I invent a special symbol, with the letter I or something. Or maybe something that has angle brackets, I don't know. And then we can do complex math in a simple way, and there you go. There's the answer. That's how aggregation works. That's how marshalling works. This is how the enormously complex goings on behind the scenes in a calm environment, which is exactly the same type of environment as this, even more complicated because it involves remote procedure calls sometimes, can be made to look quite simple and easy to use for the user. Whether that's an advantage or not, I don't know. The main disadvantage, I think, with COM is it's too open. The use, the specification for those identifiers for the various types of objects and classes is confusing. It's not clear how type libraries work, how do we determine types and so on. Those are problems to do with COM that lead to misunderstandings. People don't understand what they're doing because it's so easy to do one thing, like display that animated GIF. There's nothing to it, but you don't know what you're doing. So there is something to it, but you don't know what there is to it. And that means that the programmer is lost and unsure about what's going on behind the scenes. I don't think that's a good place to be. It's not a place I like to be. I still never figured out type library. I know the general approach. A type library is yet another COM object, keeping everything the same, naturally. And through fiddling around and coming up with various conventions, this special COM object is a way in which one can determine what sorts of functions and what types of data are used with various objects. But it's all hidden, and by the time it gets in front of you, the programmer, it's in the form of Visual Basic or something. So that's not so good, and I'd like to look into unraveling type libraries and maybe figuring out how they work, and perhaps even writing something like that OLU view, but in a way that makes some sense. Okay, see you.